Today we're going to be working on Leetcode question number 93, restore IP addresses. A valid IP address consists of exactly 4 integers separated by single dots. Each integer is between 0 and 255 inclusive and cannot have leading zeros. For example, 0, um, 0 dot 1 dot 2 dot 201 and 192 dot 168.1.1 are the valid IP addresses, where the other ones over here are invalid. This one is invalid. 192.168.1 and 312 is invalid because 312 is more than 255, and the last one is invalid because we have like a character which is not numeric. Okay, given a string s containing only digits, return all possible valid IP addresses that can be performed by inserting dots into s. So so in this example we have been given this 255, 255, 111, 35. So we have to come up with all the possible combinations which are going to be the valid IP addresses. The way we're going to be doing it is recursive, and we're going to be trying all the things, making sure that when we are trying different things, we are still like up to that point we'll still have some valid combinations. So basically using the DFS, inserting some elements into the array and then removing them to kind of hit and try, or trying different combination in order to come up with a solution. So for doing that, we're gonna have a result which we're gonna be returning initially as an empty array, and then we're gonna call our helper or DFS function with the empty array, and the index initially is gonna be pointing to 0, and in the end we're gonna be returning our result. So the function DFS is basically takes the prefix array. So what are the different possible, like up to this point, what are the different numbers we still have, and the index. So the first thing we want to try is if the prefix length has become equal to 4, because there can be only 4 four numeric numbers, 4 numbers inside the a valid IP address. And the other thing we want to check is that the IDX is basically equal to the string dot length, basically meaning that we are at the last character. If that is the case, we know that this is a valid solution. So we're gonna say that gonna push the result, and the result is gonna be prefix dot join with the dot. So we're gonna join all the valid numbers inside the prefix and put them in the result, and then we can just return. So now if that is not the situation, if both of them are not true at the same time, that means this is not going to be a valid. So let's say if the prefix dot length has become equal to 4, but the other one is not true, or the other one is true but the first one, that the prefix does not have has 4 numbers. In any case, if one of them is true, that means we cannot actually go to the valid solution. We cannot reach to a valid solution. We can just return. Now if that is not the case and we're still working on it, we're gonna say that our our I is basically equal to, starting from the index, it's gonna start from the index, it's gonna go up to less than s dot length and I plus plus. Okay, now first thing we want to check is if the I is not equal to the index and the s of that index is equal to 0. So if the I is equal to index, there is a possibility that 0 is a valid solution. But if the I is not equal to the index, I is somewhere else, right? It's basically not the so basically if it is at the beginning, the 0 is at the beginning, that means it's a wrong solution, we can just return. Okay, that is one thing. The other thing we wanna come up with like we have to create the number. Okay, and then we're gonna say that the parse int s dot slice, we're gonna slice it from index to r, like the I plus 1. So now if the number is greater than 255, that means it's not a valid number, we're just gonna be returning. Otherwise it's basically we're gonna do is otherwise we're gonna say that we're gonna be adding that like the percent number to the prefix by pushing it in the prefix array, then recursing by prefix and the r plus 1, and then removing the same number, basically just popping the number from the prefix. So every single time we are adding a valid number into the prefix, recursing, and then removing it. Oops, that is I. Let's see if it passes all the test cases, and it does.